Hi everyone, I'm Shangi. I'm from Malaysia. So this session will be entirely conducted in English, and the only Thai word I know how to say is Saudi Cup. Is that correct? Okay, yeah, that's the only thing I know. Yeah. So thank you for coming today. Today we'll be talking about how you can make your Firestore web app a much more efficient one. So just a show of from the crowd, how many of you use Firestore? Anyone? Raise of hands, how many use Firestore? Okay. How many of you know Firestore but does not want to use it? Anyone? I'm sure there are some honest people in the crowd. Yeah, we have a few that doesn't want to use Firestore for some reasons, right? So today we're going to go through this as well. So for those who have not used Firestore, let me give you a quick recap what Firestore is. So Firestore is a NoSQL database that sits on the cloud. So what you can do with it, you can actually create apps that need to access persistent data across all your devices, right? And Firebase, Cloud Firestore has the ability for you to support offline persistence as well. So that's really a great product that you can use. So if Firestore is such a great product on its own, why are some people not using it? So we have a few on the left who mentioned that they don't use Firestore, and maybe this will reflect why. So based on the survey that T has done just now, right, a lot of you are on the Blaze plan, right? So how many of you on the Blaze plan? Show of hands. A Blaze plan where you pay money, one or two, quite a lot. Thank you for your support. And how many of you are on the free plan, right? Free is great, right? Awesome. So Firebase has always presented this pricing transparently in their webpage. So you can see that here it says that it has a very generous limit, right? So it makes it very clear to you that it has a very generous limit. So a lot of people get started to using Firebase it's easy to enter the market with Firebase on the free plan. But although we look at this free limit, there are some gotchas that you might face. So these are some of the common understandings or feedback I understand from people who do not want to use Cloud Firestore. So every time we talk about Firestore, we talk about how cool it is, what it can do, and how fast it get your app to respond. Everything is great. So we always get this kind of questions that people ask, right? So Firestore has a very generous free tier. Yes, yes. Is it truly free, truly generous? And sometimes you get questions like this, right? We tell them that everything is great, everything is good, but at the end, right, they usually come back to us and tell us that the cost is one of the major issues as to why they decide not to use Firestore. So anyone here relate to this sort of sentiment with Cloud Firestore? Anyone? No one? No one? Then I think my job is done here today. Right, so let's take a look at a common consideration you as a developer should do, right? So as developers, we try to take as little effort as possible to quickly build our products up the ground, which Firebase is really suitable for you. So as an engineer, we have to be mindful of what sort of data that we are calling from Firestore for your app. Although everything looks fast, everything is easy, everything works, but you as an engineer have to be mindful about the cost that could incur when you just use Firestore. So this session is not to drive you away from using Firestore, but it's to encourage you to see what patterns that you can employ if you're considering using Firestore, or if you're already using Firestore, how you can reduce your cost effectively. So let's say I want to build a shopping website, right? I'm sure one of the few very famous shopping e-commerce sites we have is, what do you have it? Lazada, right? You have Lazada here, right? So let's say you want to build a competitor called Ladazza, right? So FYI, this is a furniture shop in Malaysia. I don't know whether they purposely named it Ladazza for copyright reasons, and they have an online storefront. So let's say you want to build something like this, right? You want to build your own version. And you have your own homepage as well that lists a lot of different products, right? So let's just say this is your mock-up, your investors. You present to your investors like it looks like this, right? Let's take a look if I want to show 20 items. Hold on. If I want to show 20 items here, right, in your first page. Oops. Hold on a moment. Yep. So let's do a quick estimation of how much it will cost you just to load that 20 items on the page. Let's assume you have about 10,000 monthly active users who visit your website, and you want to display 20 products on your page, right? And as you know, users like to refresh pages all the time, right? So let's just give a more optimistic number of 5 page reloads and also 5 page refreshes. So they refresh the page 5 times, they navigate back and forth 5 different pages of the same products. And this is how much it would roughly cost you to read those documents if you're using Firestore. So you will probably use around 5 million document reads. So show of hands, how many of you think 5 million document reads is expensive? Anyone? 1 or 2, right? So 3, we see that this number itself sometimes scares the user, right? Scares the developer or even scares whoever's paying your salary, right? So 5 million document reads, if you look at the Blaze calculator, you would see that roughly it costs you $2.10 USD, right? So do you think this is a good offer, or this is a good price to pay for making sure your systems are working in good order, everything is fast, and everything's blazing just to serve that 10,000 daily monthly users? I think it's great. This price is great. But then again, you come to some of our perceptions that the developers have. Then why do they think Firestore is expensive if it's just only going to cost you $2.10? Let's take a deeper look. So although this works, right, the cost is low, as a business, in the end, all the products that we are building are meant for businesses, right? We are here to make money. So money has to come from somewhere, right? So as developers, you have to be mindful about the cost itself, the upfront cost and the cost of maintaining and the cost of scaling your products. So you have to be mindful about how much it might cost you down the line if you were to grow into a very successful business, right? So let's go ahead and take a look again at the product that we want to create here, our website they want to create. And let's take a look at the key common APIs that Firestore has to offer, right? Let's say you have a requirement where you want to show the top 10 sales of the week, right? So every week, this list will change, right? So this entire list will change. Every week, it will change once. So you are presented with 2 options on the API level. One is get docs, and one is on snapshot. So let's take a quick recap of what each API does. So we have our get docs. Get docs basically means to get the documents in the collection. That's simple as it is. And on snapshot is to get the documents with an event listener that listens to data changes, right? So all of these 2 APIs, both can be used to retrieve data. You as a developer, what do you think is a better option? How many of you think get docs is a better option to solve this problem, this requirement? 1, 2, 3, 4. How many of you think is on snapshot? Okay, we have quite almost the same number as well. So let's take a look at how these 2 performs differently. So let's take a look at get docs. The get docs API, with the same amount of transactions that we're doing, will produce you 400K document reads. But let's take a look at on snapshot. On snapshot, we'll actually reduce this count by 200,000. So you might be wondering why. Why does it do that, right? So you can say this small change alone can significantly save a lot of your reads, almost 50% of your reads, right? So let's take a look at why. Because does this mean that on snapshot, you should use it all the time for every single query you're doing on your app? So let's take a look at that. So we go through our getDocs first. So how does getDoc work? When you call the getDoc API, which is through the Firebase SDK, you're fetching data from the Cloud Firestore. And that's it. You need 10 records, it returns 10 records. You need 100 records, it returns 100 records. If 10 users are fetching 100 records, you are returning 1,000 reads. So it's pretty much standard. So how different is on snapshot? When you query data with on snapshot, the same thing happens. It queries the data you need from Firestore, but only as fresh reads, meaning when you reload your website by clicking on the refresh button, the data is returned and is cached for you so that it knows when the data has changed. So when you visit other pages or you navigate back and forth between other categories of products and stuff like that, you will not cost more reads than is needed because it first fetches from the cache itself. So assuming that there are no new data coming in from Firestore, you basically save a lot on your reads. But let's say you have other sort of scenarios, right? So let's say your website is doing good. Now you want to do this flash sale sort of feature that you want. You want to display the top 20 products that are on sale today so that users can buy. So does it mean that every day it will refresh 20 new products, right? So let's say the same app now, right? And now suspiciously it has the same features as the Lazada app, right? So now you have a sale and you want to be able to target the sale tomorrow. So let's say someone's offering you one item for just $1. Is $1 even a thing? Yeah, I think so, right? So let's say you get really cool stuff for just $1, and everyone's just gonna refresh this page, right? Gonna refresh until exactly 12 a.m. This hits, right? I'm sure a lot of you recognize this, right? Just waiting for 12 a.m. for the sales to kick in. And let's do a quick count of how it would cost you with on snapshot, right? So again, on snapshot, you have 10,000 daily active users. On the same sales, you have 20 items, and this time they spam the refresh button 20 times. Since you're going to press the refresh button, you're going to be charged the same count as using get data versus on snapshot. Because every time you refresh, the snapshot listener gets removed, get destroyed, and recreated again. So in this scenario, there is no difference with get docs versus on snapshot. So what do we do then? So there's a lot of ways you can solve this, but one of the few ways you can do is to make sure that the results can be stored into the cache itself by explicitly asking for it. So earlier in the demo you showed just now, the on snapshot itself handles the cache, but it does not handle the cache if you refresh the page repeatedly. So how can we explicitly create a cache? So just like on snapshot is very similar, but instead this time we explicitly call a method called getFromCache. So you call the getFromCache to start storing data in caches. So let's take a look at a quick sample code of how this will look like. In order for you to enable a caching strategy, you first must enable offline persistence. In this case, the default one is IndexedDB. So if you don't do this, you don't get to use the caching function. So in this case, I'm querying the Firestore to get the list of products, right? And in the products, right, I'm going to cache it. So in the event the cache is empty, we have to call Firestore again to get the list of cache. So assuming you're at 12 a.m., right, when you refresh the page the first time, you get no results because you don't have the cache, right? So you call Firestore again, get the cache, and store the cache. So next time when the user refresh the page, since you already know at 12 a.m. the page will always stay the same, right? Because we are doing a top 20 daily products. So in this case, you just get docs from cache instead, so you don't have to purposely query the Firestore again. So this way, you are bypassing Firestore and just immediately getting from the cache. So this works if you know how your cache will look like and your cache doesn't get updated often. So in this case, what will happen now is that if you were to implement this solution and deploy it, you will get this sort of result. You will see that the number of reads has dramatically dropped because most of the time the data comes from the cache and only on first load, you get it from Firestore itself. So although that solution works, there's still some ways we can further improve this solution, right? Since we know that every single user at 12 a.m. will see the same list of flash sale products, what can we even further do to even reduce the number of reads? So let's say these 5 different users really want to purchase that one bud item that happens on 12 a.m., right? So what they need to do is they just click spamming the refresh button, and we all know that the data is the same. What we can do to solve this is by using bundles. So what are bundles? Bundles are basically a way Firestore allows you to package these results of your query and serve it from somewhere else other than Firestore. So basically, think of it as a view from a SQL database point of view, or think of it as a cached result that you store somewhere. So this allows you to query data directly from these bundles rather than querying from Firestore. And you only need to generate the bundle once. So let's take a look how it will work, right? So let's say you already know what are 20 products that you want to promote by 12 a.m. So what you do is you need to have a cloud function or some sort of secure environment. It could be your own backend Node.js app, or it could be a cloud function. So what will this cloud function do is to query the data on behalf of the user. So if I know the top 20 items are what I can do is that I can query these items from the cloud functions or your backend environment, generate the bundles, and just build it. So what happens at the end, it gives you a binary object that you get to store anywhere else. You can put it on cloud storage, you can put it on your own CDN, or anywhere that you will feel like it. So here's a very simple sample code how it will look like. So let's say you want to create a bundle of the latest products of today, right? Then you create a bundle, and then you query what you want from and put into the bundle itself, and then you build that bundle. So now, with the bundle buffer, you can do whatever you want. You can save it in cloud storage. You can save it somewhere else. You can even download it or whatever that you would like. So once you have this bundle, all you need to do is to distribute it to all your users. So all your users will immediately hit the bundle instead of hitting your Firestore. So what it does is that, very simple, once we have created our bundle, we can save it in our cloud storage or whatever remote storage that you like. And all your app does is just to fetch that bundle. So here's a very simple sample code of how it will look like when you want to retrieve the data from the bundle. So this is your client-side code. So in this case, maybe your data is stored into an API somewhere on your back end. Then all you need to do is to get the data from the bundle API. And then you just load the bundle into your Firestore, and basically that's pretty much it. You have to make sure that you always include the source cache before it actually gets the data from the bundle. Otherwise, it will always get from the remote and always get from Firestore. So be sure to always add the source cache inside. So that itself will actually drop from 200K reads to almost 20 reads instead for all of your users. Of course, this is just the amount of reads that will be charged to you, but it does not include the amount of bandwidth that you need to transfer the data over the wire. So the bandwidth costs, etc., will still be charged. But this is a lot of an improvement compared to previous approaches, right? Because now the back end is, or rather your cloud function is doing that querying for you, and you only queries once. So although with that out of the way, right, as developers, we know that the more code we write, the more bugs we get, right? So the more problems we solve, other problems will still arise from this. So one of them is that, let's say you now want to do something else. Let's say you are building an app that downloads a list of users, maybe a few 10,000, 20,000, or even 1 million users, right? And you know these users don't change often. For example, maybe your employee record or something like that. And we know that since this bundle contains every single record you want, there's a chance that this bundle can get big very fast. So you have this issue of the data over the wire getting too huge for you. And once we have this data, normally we want to search this data, right? We all know on Cloud Firestore, it's easy to do searching, right? You just search and it's expected to give you the same performance between one item out of 100 versus one item out of 1,000,000. But this problem will happen if you were to use bundles. And one of the few ways you can solve this is by using client-side indexing. So just a quick recap of what is client-side indexing or indexing in general. It's a way for things to be searched easily or faster, right? So in Cloud Firestore, when you were to create collections of documents, these documents fields are indexed automatically by Firestore unless you query different things. So what happens in Firestore is every single field you add in Firestore, or rather in a document, automatically Firestore will create every single index for every field. So the same thing is happening for what you should be doing for your client side as well. So with indexing, what happens is that every single field will get indexed as a key so that you can easily search it as it directly gives you the location of the object through the object ID, right? So this indexing is a very general concept that is used across all sorts of products or technologies to speed up queries. And we need to apply this to our Firestore bundles as well. So you can generate the bundles however you like. You can manually create them, or you can also download it from the Firebase console for your Firebase documents. And all you need to do is to put this index somewhere and just set the index configuration. And that's it. You would have the same indexing power as Firestore. Of course, it's limited to your client-side hardware performance as well, right? And other considerations. But in this case, you no longer are burdened with the need to query things slowly by going through every item. So this tries to simulate the Firestore back-end indexing mechanism. But of course, this is a lower powered version, a lighter version for you. So end of the day, the question, if we know that bundles are really great, it saves a lot of costs. Most of the time, we will ask ourselves, whether should we bundle everything? Should we just take everything else and bundle? So the answer here is no. There are some reasons why you should and why you should not bundle. Let's take a look at some scenarios where it will make sense. If you're going to load data that will be the same across all users, for example, a list of product categories that doesn't change often, it's a good way you can store it in bundles because you don't need authentication, you don't need any sort of special means just to display this information. But you want to be able to have a way to change this in the future. Let's say you want to add a new product category, or you want to add a new sale category, etc. Right? Then this makes a lot of sense. And it's also useful to use it on products that people see before they log in. So things like your product page, or let's say your articles, if you're building a news website that you don't need people to log in to see, those are really great examples of why bundling makes sense. What it doesn't make sense is that if it's going to be changed often, right? If, let's say, we're talking about product sales, right? Number of products that you're selling, or every day there are people buying that same products, or let's say you're building a social media app, and that social media app allows you to add comments. These are not really good examples of using bundling because people can add them all the time. So if you were to create bundles on data that changes often, it basically has no point because you have to rebuild the bundle over and over again just to serve the refreshed data to the users. And as a side note, we don't want to create bundles of sensitive information or private information, or basically information that is hidden behind a user login flow. Now, the reason for this is that bundles itself, when downloaded, they are not encrypted. They are plain text. So you should not use this to store user information because other users or bad actors can basically just download this information elsewhere and they can just view your data directly. So let's say you feel that maybe bundles are not really your thing, or you feel like, let's say you want to implement this as soon as possible in your app, that is having some sort of emergency where the data are being, your costs for downloading data is high, or high billing rates, and you need to fix it as soon as possible. Maybe your boss says that we are hitting a few 100 million data reads right now. I need you to fix this by today. And it will take you time to do bundles. So what are the alternate solutions that you can try to achieve almost the same effect? Consider using real-time database as well as your Firestore as a part of a hybrid solution. So why do I say this? So for example, let's say you're building your e-commerce app, right? And your e-commerce app itself has 2 pages. One is your cart, a list of items you add to cart, and you basically just have promotions. We know that the promotion don't change often, but we know the cart users always interact with. You can split these 2 sources of data into 2. One on cloud storage, one on real-time database, and one on Cloud Firestore. And with out of the way, there are other problems that you'll face. One of them is the minute size of a collection. I think T earlier on showed you this really cool feature. I'm going to show you an example of this. So let's say you have a product, right? And that product itself, you will need to see the number of users who purchase it, right? The translation is orders, right? Number of orders, right? Yeah. So if I want to display the number of people who ordered this product, what you can do is that you can use a new feature from Firestore that T has gone through just now. Let's take a look. Let's take a step back and see how it was done before that feature was released. I'm sure some of you might have done this already, where how do you determine a size of a collection? A lot of engineers, a lot of developers will actually just query the orders and use the size property to give you the list of items. How many of you do this at work or in your projects? None? Or 1 or 2, or you're too shy to say? But nonetheless, this is a very common occurrence that developers make to get a list of orders of your products, or list of basically a count of your data, right? So let's take a look at the performance impact in terms of cost here. So let's say 10,000 users are accessing the same Shopee item, the listing just now. Pretend I didn't say Shopee. So that itself, and there are 100 orders being made to that particular item, right? It will cost you 1 million document reads just to load that particular page. And why? Here's why, right? Every time you call the database, right? Every time you call the database and every time you use the get size, what happens from Cloud Firestore is that it actually queries every single record and does the count itself. So you're basically querying 100 items per user every single time you reload that page. So that's not something you want to get, right? So the solution here is to use aggregate queries that was shared earlier on, which is really great. So all you need to do instead is to change your code to just call get counts from server and just put in your Firestore query. Just put in your query in it. And here's a very simple sample code, right? It's very simple to do. Just query your data as normal, nothing fancy, and just use the get count from server. So what is the output here instead? So instead, what you get is that you get 10,000 document reads from the 10,000 users who first loaded the page, and also an additional of 1,000 reads for the 10,000 users. So it's not 1,000 reads per user, but collectively for everyone, it's just 1,000 reads. So you can compare the difference is really vast. So the reason why you actually charge an additional 1,000 reads is that the get count from server is charged based on the number of indexes that is available in your document. So it has to go through every single index that is available for your collection for you to get this number. So it's a lot cheaper than just using the get count. So this is a really great API to try. So in summary, let's go through what are the things that you should be trying out in your Cloud Firestore. You need to understand how Cloud on snapshot and get documents work behind the scene for you to understand what are better strategies and what are not. So you have different use cases and different ways to use it. There's no right or wrong. So evaluate your own requirement, evaluate your own business, how your business operates, and figure out the correct API to use. If you think that bundles really help solve a lot of your problems, or you think is suitable, go ahead and use it, and I can tell you it really saves a lot of your time. If you're going to use bundles, make sure you also include client-side caching so that you're able to search the data you need as fast as possible. At the same time, if bundles are not your thing and you feel like there are some limitations from bundles that you want to overcome or circumvent, consider using real-time database, as you can always safeguard this storage through security rules, right? And always choose aggregate queries instead of counting data manually, because cheaper in this case is always better. So with that in mind, thank you.